The next important part that we need to speak about, continuing what we talked about last time when we mentioned the number 6.02 multiplied 10 to the power of 23, you should know that the name of this number is Avogadro's number. So what is Avogadro's number? This is a big number. It represents the number of particles in a mole of substance. The mole can be anything, like we said when we explained last time about the pair and dozen. You can have a mole of atoms. That's Avogadro's number of atoms, 6.02 multiplied 10 to the power of 23 atoms. Mole of ions, that's 6.02 multiplied 10 to the power of 23 ions. Mole of molecules, that's 6.02 multiplied 10 to the power of 23 molecules. Let's make a review again about what we explained last time. What is molar mass? That's a mass of 1 mole of substance. So if we define the molar mass, that is the mass of 1 mole of substance. What is the unit of molar mass? The unit of molar mass, in order to know the unit of everything, see how did you calculate it. So that was molar mass. You find it by finding the mass over the number of moles. So since it is mass divided by number of moles, so it is the unit of mass divided by the unit of number of moles. The unit of mass is grams, and unit of number of moles is mole. So what is the unit of molar mass? That's grams per mole. How can we calculate the molar mass of something like water? When you go to the periodic table, you will see that the hydrogen has a mass of almost 1. And there are 2 atoms of the hydrogen, so that's multiplied by 2, while oxygen has almost a mass of 16, and there is only 1 atom. So if we added these 2 plus 16, we'll get a mass of 18. Please note that the numbers in your book or service might be a little bit different, so you have to be very careful and use your own periodic table so you can get the numbers correctly. Let's talk a little bit about dimensional analysis because it's going to help us a lot in our exams. Dimensional analysis is a method. It will help me to convert one unit into another. So I use something called conversion factors. It will help me to convert from one unit to another unit. Let's see an example. I need to convert 5 moles of water into molecules. I will say like that. The 5 moles of water, we know from our conversion factor, so we'll use the conversion factor. What does the conversion factor say? The conversion factor tells me that in every mole of the substance like water, there is 6.02 multiplied 10 to the power of 23 molecules. When you try to make the conversion using the conversion factor, all you have to do is write these 2 numbers. So I will write the number 1 mole and 6.02 multiplied by 10 to the power of 23. But always note that you will need to cancel out these 2 numbers, but you cannot find anything to cancel this with. So this one and this one should be in the way to make them canceled out. You cannot find moles here. So that's why you have to remove the moles and keep it at the bottom, and remove this number and keep it at the top. So you need to arrange your conversion factor correctly so that the numbers cancel out. So now the mole can cancel with the mole, 1 in numerator and 1 in denominator. So just multiply the 5 multiplied by 6.02 to the power of 23 multiplied by 10 to the power of 23, and you are going to get 3.011 multiplied 10 to the power of 24, and the unit comes out automatically. This is 1 mole, and this is 1 molecule. So here molecule comes out automatically. This is the best thing about this conversion. If I want to convert 50 grams of H2O 2 moles. Again, the conversion factor tells me that there is, this is my conversion factor. What does the conversion factor tells me? Comparing the grams to moles. So now I'm comparing the grams to moles, which is a little bit different from what we did last time. First, we'll need to know how many moles represent how many grams. We know that number of moles is equal to mass over molar mass. So what is the molar mass of water? The molar of mass of water, you can find it from the periodic table. As we said here, 2 into 1 plus 1 into 16. So that's equal to 18. This means that 1 mole of water will give us 18 grams per moles. So 1 mole of water has 18 grams as a mass. So if, again, I need to convert 50 grams, I will put the conversion factor so that the grams come down. So it will be 18 grams, so that they will cancel out, as we said. And here, 1 mole of water. But then we'll cancel this with this, and then we'll divide 50 by 18 to get the number of moles. If we divide 50 by 18 on the calculator, so we'll get 2.78 moles of water. The third example, I want to convert, this is number 3, that was number 2. I need to convert 1,000 atoms of oxygen to moles. We know that 1 mole, there is 6 multiplied by 10 to the power of 23 atoms. So again, 1,000 multiplied by, is it 1 or 6.02? This is 1,000 atoms, so the atoms should be down here, 6.02 multiplied 10 to the power of 23 atoms, and put the moles here. This means you are dividing 1,000, cancel this with this, by the Avogadro's number. So you are going to get almost 1.66 multiplied 10 to the power of 21 atoms. I'm sorry, moles. Sorry, moles. Because the moles is coming out here. So how can we use the dimensional analysis with moles and molar mass? Let's have 5 more examples. We need to convert, and this will be like homework, convert 10 moles of CO2 to grams, convert 5 moles of H2O to grams, convert 50 grams of CO2 to moles, convert 20 grams of H2O to moles, convert 1,000 molecules of CO2 to moles. How can you find the number of atoms of oxygen in water? This is a water molecule. 1 mole of H2O contains how many moles of oxygen atoms? If it is 1 mole, it will give me 1 mole, because H2O breaks down to give me 1 H only. So 1 mole of H2O gives me 1 mole of oxygen atoms. And you need to find the number of atoms. So multiply 1 multiplied by 6.02 multiplied 10 to the power of 23. That's 6.02 multiplied 10 to the power of 23 atoms of oxygen. If you didn't understand what happened exactly, you will understand when I ask you about the number of atoms of H2O, of H in a molecule of water. So 1 mole of H2O actually contains 2 moles of H atoms. Why is that? Because each molecule of water will give you 2 H's. So if you have 1 mole of water, how many atoms are there in 1 mole? That's 1 multiplied 6.02 10 to the power of 23. Then you multiply this by 2. So you will get double the number. So instead of 6.02, you will get 12.04 multiplied 10 to the power of 23 atoms of oxygen. We'll have an MCQ quiz and homework, and then you have to answer this once also before you come to the next session.